Here are the answers to the problems on stability and elasticity in question 1. The first condition is that the total forces up should be equal to the total forces down. So F1 plus F2 should be equal to the sum of the two forces down. And then you calculate the torque about A. When you do that, you see that there are two clockwise torques, 1, 2, and there is one counterclockwise. And I have assumed that the length of the beam is 1 meter. That's why you have 1/4 here and half. And since F2 is at one end, you have 1. So the two clockwise torques, when you add them, should balance the counterclockwise torque. And you get the answer. After you get F2, plug it back into the equation here and get F1. In number 2, you have the two strings and the tensions are F1 and F2. And the only down force is due to 180 grams, which you change into kilograms and then change it into newtons. And then they calculate the torque about A. And so you find there is one clockwise and another counterclockwise. And that gives you 1.764 times 0.5 is equal to F2 times 0.9, from which you can find the force F2 and then plug it back into this equation to get F1. In this question, you see that the vertical line that you draw from the top, this line, is off the center. The center is here. So that's the axis of the tower. And tan theta would be opposite side, which is this, 4.5, by the adjacent, which is 55. Or if you look at the center of gravity and drop a vertical line from there, the black line here, we could calculate x from that little triangle here. Because these are two similar triangles, you could write tan theta also as x, which this is x, divided by half of 55, which is 27.5. So that gives you the two ratios, and from which you can calculate x as 2.25 meter. Now, since the total radius is 3.5 meter, and you've already moved out by 2.25, what remains is 1.25. That is for the vertical line from the center. Therefore, the vertical line from the top could move even more. Actually, it could move double that. So it could move double this, which is 2.5 meter. Coming to elasticity, Young's modulus is given by E or Y is equal to stress divided by strain, but you flip it over and multiply. So the original length in meters, the extension, the force causing the extension, and the area of cross section, pi r squared. Just plug the numbers in carefully and you would get the Young's modulus in pascals. Number 4, bulk modulus is change in pressure times volume divided by the change in volume. One probable mistake here, not by a huge amount, but is actually the change in pressure is not 200, it's 199. So it would be better if you calculate this with 199 in place of 200. So when you do that, you get 199 times 1 atmosphere is exactly 101325, but you may use 10 to the 5 by the bulk modulus of cast iron, and you would get approximately this number. But the problem asks you to give the answer as a percentage, so multiply it with 100 and you get the answer. In question 6, you have to look at this point A and know that if this aluminum wire had not stretched, that point A would have been here. So that length is the original length L, which is this one. So from the figure you know that this is the change in length. Therefore, when you look at this bluish right angle triangle, you know this is delta L plus the length, while this is just the length. So cos of this angle, cos of the angle is adjacent side, which is the length, divided by the hypotenuse. That's what is written here. From there you can flip both sides over and then divide each term, so you get 1 by cos theta is delta L by L plus L by L is 1, and then make this the subject to get 1 by cos 12 minus 1. Now the reason why we did this is because the force is already given as 245, and then Young's modulus is this, and you make the area the subject, you have L by delta L here, but remember that what we had is the opposite, so that's why I put 1 by this and you get the area. Well, I've not completed the problem due to lack of space on the screen. What you got to do after this is put A is equal to pi r squared and find the radius. Put A is equal to pi r squared and find the radius. In the 7th question, remember gigapascals is 10 to the 9, and the change in length by original length is given as a percentage as 0.03, which means it's 0.03 by 100. That's what percentage means. And area is pi r squared, pi and r squared. So that's the equation. Make the force the subject and rearrange and plug in the numbers to get 188.4 newtons, which is the force. And since the problem asks you to find the mass, put F is equal to mg and find the mass. That's 19.22 kilograms. In the last question, that's the position of the truck, and actually the total height of the truck is immaterial. You don't need it. It's just given to throw you off. What's important is the height of the center of gravity above the base. So that height is given as 2.2 meter. And also the width of the base. You know, for stability you need to have the width of the base as big as possible and h in this case as small as possible. So now from the figure, the truck is tilted just to the boundary condition. That means if you tilt it a little bit more, it's going to tilt over or topple over. So from this triangle, tan theta here is opposite side, which is actually x, opposite side by adjacent side, h. And so you have both 1.2 by 2.2, and that gives you 28.61 degrees. Thank you.